Hello and welcome to my channel. I am Professor L and this is another live stream for math help. So if you're out there and you want to give me a problem to work, you're welcome to put that in my chat. And in the meanwhile, I am just going to be working on my board. I picked another applications problem to work out. And we'll just see how this goes. So it's a right triangle application involving distances. And what this one is asking us to do is to estimate the width of the river. And I looked at this problem and I solved it a little bit differently than the chat GPT said to solve it. So I'm going to show you how I chose to solve it. And hopefully me working this out will help some of you all. All right, so we'll just label this right triangle. Let's pick up the wrong one. All right, many applications for right triangles out there, but I'm just sticking to the ones, the basic ones for now, and maybe we'll later on get into the more complicated ones. All right, so very most important part of this is to get an accurate sketch of what's going on. I actually posted this on my YouTube on post so that I would not have to write this out. So if you look at the post from today, you can see this problem, but I'll go ahead and read it. It says a tower that is 20.7 feet high stands at the edge of the water on a riverbank. So the very first thing that I'm going to do is I'm going to draw this tower, and we'll have like a bank of a river. We'll say that's the riverbank. What about this tower? Did I pick up the wrong marker again? See if I can, oh yeah, this one's much better. Okay. So I'll just take a moment to kind of accurately sketch. I assume it's probably like one of those cell phone towers or something or other. And it's got those cables, support cables and whatnot. But this is not a very big tower. Maybe it's just for the lifeguard or something. It says it's 20.7, I believe. And it says from a point directly opposite on the other bank above water level, there's an angle of elevation. So at some point on the opposite bank, so we'll just say that this is the bank of the river. And if there is an angle of elevation or an angle of depression, the key to that concept is its line of sight. So what you'll do is you might have a person standing here. It can't be an angle of elevation or depression if there's not somebody viewing it. So this is a viewing angle is what this is signifying. So we'll just do a little, I like my stick figures to have like ball caps for some reason. I don't know why. But we've got this person that is viewing the angle of depression and elevation. And So what you have is you have this line of sight here. And then if you're looking up, it is an elevation. And if you're looking down, it's a depression. And that's what it's called. So that's what it's referred to. So this one is giving us, this problem is giving us a elevation angle to the top of the tower, and then it's saying that there's an angle of depression on the image. So apparently the reflection in the water is casting an image of this tower here. So let me see. Use my art skills, see if I can draw an upside down image at some point. We've got this tower. And let's see if I can do. It's hard because, we're getting in a hurry, just trying to get all this done, but we forget to have a good time and make sure that we're get an accurate sketch here. All right. So you have this reflection, and then let's see, we've got the bank, and then we've got some water here. So I'll just finish that water. Maybe, I don't know, something like that. And we'll have to cut it off at some point. All right, so I've got this, and I'm in such a hurry, and then I want to make it perfect, so. All right. And so it's saying that the angle of depression of the image of its top in the water is 38 degrees and 12 minutes. So we've got another angle here of depression here. So I'm going to go ahead and draw these out. Here's my triangle here. And then I also have a triangle here. And I have these angles. So it's giving me the angle of elevation. We'll label that alpha. And then it's giving me an angle of depression. And I'm going to label that beta. Okay. And we've got this. So we've got the entire height of the tower is 20.7. And then we've actually got this height of the person to contend with here. So we've got this line of sight. And line of sight is, it's at eye level. All right, so we've got the accurate sketch set up. So we're going to go ahead and just put in our values now. Alpha was 27 degrees and 17 minutes. And beta was 38 degrees and 12 minutes. And if we wanted to, we could go ahead and plug into the calculator and get a decimal for 27.17. 27 degrees and 17 minutes is approximately 27.2833 repeating. And then we'll do the same thing with the beta angle, 38 degrees, 12 minutes. And I'm getting 38.2. And what we're going to do is we're going to use a little bit of trigonometry now. So we're looking at this thing right here. We've got, let me change where I'm going to put this. This is 20.7. And so here, this is also, let's see how we want to draw this. So this is also 20.7. Okay. And then I have this person's height in here. And notice that there's more length down here than there is up here. So because of the person standing here, we're going to have to subtract the height from above water level, and then we're going to have to add it here because it's not, let's see, 20.7 is about right here. This is about where it starts, somewhere in here. Wherever that tower is going to start in the reflection. So he starts viewing that tower, and it's here 27, but we have an extra amount of H here as well. So we're going to end up with, for this triangle, we want this triangle right here. And then we're going to use this triangle here. So this first triangle, let's draw it out. The slim one looks like this. We got our right angle, we've got alpha, and we've got, this one's going to be 20.7 minus H. This distance, because it's just here subtracting from the man. And the width of the river. And then we have this big triangle down here. Let's sketch it out separate so we can list the values. And this is our right angle. And we have this angle beta. And then this distance is going to be 20.7 plus H. Because we're taking that, we don't need it twice, just once. Since we have this reflection in here, that's 20.7, we have to add in this portion of that triangle from the line of sight. So it's that technical detail. And so then this would be W. All right. So I have my triangles. I have my values of what I'm going to go ahead and plug in. So for this one, we'll go ahead and set up the trig equation, and then we can kind of put it all together. We're going to use tangent because it's the side lengths. We don't know anything about the hypotenuses. So we're going to say tangent of alpha equal, and then its opposite, which will be 20.7 minus H divided by adjacent, which is W. And then the same thing here for the beta is opposite over adjacent. So we'll say tangent for this one of beta is going to equal 20.7 plus h divided by w. And then how I chose to solve this was I solved each of these for w and set them equal to each other, and then figured out what h was. So that, I think that's probably the best thing to do. So we're just solving this for w with cross multiplication. That's going to give you w tan alpha equal 20.7 minus h, and then you're just dividing off the tan alpha. And so then here we're going to get w is going to equal 20.7 minus h. Oh, I ran out of room. Let me put it. Let me see if I can just sneak it in here. I'm going to erase this one and put it underneath. W equals 20.7 minus h divided by tan alpha. And then down here, where we have tangent beta equal 20.7 plus h over w. So we're just going to solve this one similar manner using that cross multiplication. It's going to give you w tan beta equal 20.7 plus h. And then we're going to divide off that tan beta. And then you're going to end up with w equals all of this. Those cancel. 20.7 plus h divided by tan beta. All right, so since you have what both of these are equal to, you can set them equal to each other, which is what I did. And then I solved for solved for h. So we have w. Sorry, I don't need w. I'll put it over here. So I'm going to say 20.7 minus h divided by tan alpha equal 20.7 plus h divided by tan beta. Now all I'm going to do is cross multiply. So you're going to end up with tan alpha times 20.7 plus h equals tan beta times 20.7 minus h. And then we're going to distribute. So you'll end up with tan. I'll put the number first before the letters. So you'll say 20.7 tan alpha plus h tan alpha. And then here you've got tan beta. 20.7 tan beta minus h tan beta. All right, we're not finished yet. We're going to group now. So everything with an h is going to go on one side of the equal sign, and everything that doesn't have an h is going to go on the other side of the equal sign. So right here, this negative h tan beta is going to get added to both sides. And when I add h tan beta to both sides, I'm going to get 20.7 tan alpha plus h tan alpha plus h tan beta, and that equals 20.7 tan beta. And subtract the tan alpha from both. This one right here, 20.7 tan alpha. And I knew that this was going to get crazy, but I think it's going to work out. We're almost finished. Minus 20.7 tan alpha. I can't combine those. I know that. So we're going to factor out an h from these two expressions here. So this is going to be h times tan alpha plus tan beta. And then this equals, we're going to have to move it. All right. I am running out of room. Let me see if I can put it in here. So we have h tan alpha plus tan beta equals 20.7, and I'm just going to go ahead and factor out that 20.7, and I'll say that that is tan beta minus tan alpha. I think that that'll cover that because it's 20.7 tan beta minus 20.7 tan alpha. So if I just factor out the 20.7, then I can condense it, which is just helping me to shortcut it until I plug in my values. So we got tan alpha plus tan beta from both sides. Beta. There we go. Those will cancel, and I'm going to end up with h equals all of this. So we've got 20.7 times the tangent of 38.2 minus the tangent of 27.3. I'm just going to abbreviate that one, or round it to the 10th place. And then that's divided by tan of 27.3 plus tan 38.2. And this is what you literally put into the calculator to figure out the height. And what it's giving you is the height of the human being that is viewing the site. Okay, I remember look at the camera. What that is telling you is that it's only giving you this height here. So what we need to do is, in order to get the water length, we're going to find the approximation for this by plugging it in the calculator. And what I did when I plugged it in the calculator is I just put an extra set of parentheses because of the division. And you can just plug all that in. So 20.7, and I'll just tell you, I did a parentheses, 20.7, another parentheses, and then tan 38.2, close your parentheses, so you have two more, minus tan 27.2 3. Close those parentheses, and then as long as you close them, so that works out, and then divided by, 1, 2, 3, 1, 2, 3. I gotta have one more in there. All right, so that's divided by 10, 27.3. I forgot to put my second parenthesis in there. So before 10, after the division, you want to go ahead and put a parentheses because it's a syntax issue. So plus 10 of 38.2. All right. And let's see what I did wrong because I'm not getting the same answer. Okay, 20.7 times 10, 38.2. And this is the tragic part. This is it. It's not giving me the right answer. Minus 10. Let me just see if I can figure out the syntax where I made a mistake real quick. Second insert. Maybe. Okay, so you got to be really careful. So I missed a parentheses in there, and I'm getting, but regardless, you'll get 4.308653893. All right. So what we have here is the person's height is approximately 4.3. Okay, so we're just going to round it. And we really need to approximate that right there. All right, so what I have to do is, in order to use the smaller triangle to figure out this length here, I've got to subtract the height from the total height of the tower. So we're going to say 20 minus 4.3. So the height minus the tower equals 20.7 minus 4.3. I'm getting 16.4. So 20.7 minus h is 16.4. So that is the length that we're going to have to use for this calculation. So now it'll be easy. So we're going to say 10 alpha. And instead of alpha, we'll go ahead and plug in alpha this time. 27.283 equals opposite over adjacent. So that's 16.4 divided by W. And then now all we have to do is solve for W. That's a 1, sorry. Cross multiplication. And then we'll get W 10, 27 point, we'll just say 3. And that is going to equal 16.4. And then we're going to divide off the 10, 27.3 from both sides. And that's going to give you the length of the water, the width of the actual river. And that is, you plug this in. So you'll plug in 16 divided by 10, 27.3. Right. And I'm getting 31.77 44179. And this is feet. So there's the length of your, or the width rather, of your river, your creek that you're in. And that's if angles are known. So, all right, that is pretty much the solution. And I'm trying to keep this short and sweet, so that was already 30 minutes. I will go ahead and stop there, and I know that seemed like it went by really fast. And it was a little bit all over the place, but I will reflect and we will come back tomorrow and I will try something new. Try it again. Probably going to move on from applications on right triangles unless somebody sends me a problem they want me to try to work on. And yeah, so we'll just go ahead and end the stream there. And I will be back again tomorrow, same time, same place. And thank you so much for watching my video. And I will see you again next time. Bye.